Welcome, focused learners, to another explainer. Right, so today we're popping the hood on a tool that literally runs the modern web. I'm talking about Python. And hey, fun fact, it was actually named after the comedy troupe Monty Python, not the snake. Pretty cool, right? It's a high-level, incredibly human-readable programming language. I mean, whether you're building websites, crunching massive data sets, or training the next big AI model, Python is the engine driving it all. Here's our roadmap for today. 1. Meet Python. 2. Core building blocks. 3. Organizing your data. 4. Writing reusable code. 5. Files and error handling. And finally, 6. Object-oriented programming. Section 1. Meet Python. Okay, let's dive into this. Unlike some languages that compile everything all at once, Python takes a step-by-step approach because it's an interpreted language. When you write a .py file, well, that's your source code. The Python interpreter reads this line by line, hunting for errors. But it doesn't just run it directly right then and there. First, it converts your code into this low-level format called bytecode. Finally, that bytecode is sent over to the Python virtual machine, or PVM, which acts as the actual engine executing those instructions one by one. Section 2. Core building blocks. Just like any human language, Python relies on a very specific vocabulary, but there's a strict line between the words Python keeps for itself and the ones we get to invent. On one side, we have keywords. These are reserved, completely unchangeable structural rules like if or for. You can't mess with them. On the other side, identifiers. These are your flexible, user-defined labels, think age or name. We use these identifiers to point to data stored in the computer's heap memory. Now, how Python actually handles the data those identifiers point to is absolutely crucial. In Python, everything is an object, and they fall into two camps, mutable or immutable. Mutable objects, like lists, well, they can be changed right there in their original memory space. Immutable objects, like strings, are locked in tight. If you try to modify an immutable object, Python actually creates a brand new object in a totally new memory space. It's a really brilliant built-in safeguard against accidental data corruption. So what exactly are we storing? Python gives us 4 core types to play with. Integers for whole numbers, floats for decimals, strings for text, and booleans for your true or false logic. But here is the real game changer. The reason Python feels almost like magic compared to older languages: dynamic typing. You never have to announce your data type up front. Python just figures it out on the fly, based purely on the value you assign. Section 3. Organizing your data. And this brilliantly illustrates how we hold everything together. Once we have our individual bricks, we need containers for them, right? Python gives us 4 main options. Lists are ordered and mutable, your go-to for everyday collections. Tuples, they're basically immutable lists, which makes them safer and a bit faster. Sets are totally unordered but amazing because they only keep unique values, making them perfect for lightning-fast math. And finally, dictionaries. These use a key value structure, giving you incredibly fast access to data. It's literally like looking up a word in a real physical dictionary. Section 4. Writing reusable code. Programming is all about automating action, not just storing stuff. A highly specific and, frankly, powerful technique for this is recursion. This is when a function actually calls itself, directly or indirectly, to solve a problem step by step. Think of it like a countdown or calculating a factorial in math. You break down a massive problem by having the function repeat. But, and this is a massive catch, you absolutely must include a mandatory stopping condition. Miss that crucial stop sign, and you've just created an infinite loop that'll crash your entire program. No one wants that. On the complete opposite end of the spectrum, we've got Lambda functions. These are tiny, anonymous functions written in just a single line containing only one expression. When you need some quick, throwaway decision logic and writing out a full multi-line function would just be total overkill, Lambdas are your best friend. They're basically the quick fix multi-tools of the Python world. Section 5. Files and error handling. Let's be real. Even perfectly structured code eventually has to face the unpredictable outside world, like reading CSV files. So what happens when our code encounters an error? Say you try to open a file that simply doesn't exist, or a user types a letter instead of a number. We need a solid way to handle these real-world failures gracefully, without the whole application crashing down around us. Because these runtime roadblocks, they happen to absolutely everyone. You might get a zero division error when math goes sideways, a type error if you try to combine incompatible data types, a value error when the type is right but the value is wrong, or an index error if you're looking for a position in a list that just isn't there. Thankfully, Python provides a fantastic safety net to catch them. This four-step structure is exactly what separates amateur scripts from professional, user-friendly applications. First, you put your risky code in a try block. If it fails, Python skips ahead to the except block to handle the error gracefully instead of crashing. The else block, that runs if everything went perfectly. And finally, the finally block. That cleanup code executes no matter what happens, making it the absolute best place to securely close your files.
Section 6. Object-Oriented Programming.
So, the crucial point is that to really construct the entire house, we need object-oriented programming, which rests on four main pillars. Encapsulation wraps data and functions together for security. Abstraction hides all the messy internal details, showing only what's essential. Inheritance lets a new class steal properties from a parent class to save you time. And polymorphism, that lets different objects share the exact same method name but behave uniquely. Together, these let programmers securely and efficiently model real-world concepts.
To actually use OOP, we have to start with a class. Think of a class as your ultimate architectural blueprint. It defines the variables or attributes and the functions or methods to group related data together. But remember, a class doesn't do anything on its own. It is strictly an abstract idea, just waiting to be brought to life.
And here is exactly how it comes to life. The class is the abstract blueprint for, say, a car. The object is the actual, tangible, real-world instance created from it, like the specific Toyota sitting in your driveway. By using special methods called constructors, we can take one single blueprint class and stamp out hundreds of unique objects, each holding its own distinct data, but sharing that exact same core design. We've traveled from the absolute simplest variables all the way up to architecting object-oriented blueprints. Python's true power isn't just in its readability, it's in the sheer scale of what it allows you to build. So, now that you possess these core building blocks, what will you construct with Python? Whether it's data science, web dev, or automation, the tools are in your hands. Thanks so much for joining this explainer, and we'll see you next time.